Hello everyone and welcome back. In the previous video we solved 6 problems and we are going to do the same in this video. So let's look at problem 7 and see what it says. So yeah, this problem says that one number is 6 times the other and the difference is 30. So let me get my pen. So one number is 6 times the other. Too thick. So one number is 6 times the another and the difference is 30. These are the key words in the problem. Whenever you are solving a problem, always look for the key words. These word numbers, if they change this number and put banana, it will still not change the solution of the problem. Say one banana is 6 times another banana and the difference is 30. Find the bananas. So though it may sound funny, but actually if they change any of these letters here, it will not change the problem. But if they change 6 times here and they change this difference, it will change how the problem looks like. So those words that if they change, we change the problems, we have to get hold of them and analyze them carefully. So one number is 6 times another number. We don't know the number yet, but in mathematics we let the unknown be x. Unknown, we actually call the unknown x, or you may use y, you may even use j. One of my students usually use j, Jessica. So she usually like to use j if she wants to, simply because her name is Jessica. But you don't really have to. You can even use p if you want to. So we are told that one number is 6 times another number and the difference is 30. So we have a number here, x, and that number, the number we have again will be 6x. Since the number is 6 times another number, okay, you may even say one of the numbers should be 6x. You may even say one of the numbers should be 6x. Excuse 6x, and the other number should be x. Anyone. Just know that one will be 6x and one will be x. They are the same thing though. Just that one is 6 times the other. You may actually use one to be x and one to be x over 6, because this one is 6 times this one is 6 times of this one here. But there's no need to complicate things by putting fractions there. I will go for the simplest one. Excuse me. Why I showed that one there is just to tell you that there are alternative means of doing the same thing we are doing here now. So let's wipe this out now and see how we can solve this problem. So here now we are given one number is 6 times another number. So one of them is x, one of them here is 6x, and the difference is 30. Now this 30 is positive. Let's take the difference. This word difference means we should minus. This word difference tells us to minus. So what it means that is you may do x minus 6x to get 30, but we want positive numbers here, of course. So what we'll do is that we just put 6x minus x, so the difference, and this difference is equals to 30. So that is the second condition. So the first condition is one of them is 6 times the other, and the second vital condition is the difference equals 30. So these are the vital conditions that we must take note of if we are to solve this problem successfully. So 6x minus x is 5x. So 5x equals to 30. Now divide both sides by 5. And then x will then be 30 divided by 5 is 7. X will then be 7. The other number will then be 6x, which is now 42. So the numbers are, wait, let me see. No, x is 6, not 7. X will be 6. X will be 6. Okay, no, I thought I was reading 35, so x will be 6 here. So x will be 6 here. Okay. So x will be 6 here, and then 6x will be 36. Of course, one is 6 times the other, and the difference 36 minus 6 is 30. I knew I was wrong, because if I had 7 I had 42. I did the difference in my brain. There's no way 42 minus 7 will give you 30. And nobody's perfect. So what you usually do is to make sure you check your work. Don't be too proud of yourself and say, aha, I've gotten it. Always check to see if there's any slight mistake you made in your solution. This problem is quite interesting. Now let's look at another one, which is even more interesting. So in this problem here, we are told that in a school that 27%, wait, let me get a pen, that 27% of the pupils have had chicken pox. Just like I said in the previous lesson, this chicken pox here, if you replace it with mango, it will not change the problem. These numbers that appear that vital to solving the problem. And 35% had German measles. Okay. Now 10% have had both diseases. Then we are asked what percentage had neither. And now this is quite interesting. And let me tell you, if you are not careful, you may fail this. Here's how you may fail this problem. Let's see. What percentage had neither? I think we have to find the percentage of those who have diseases. So let's say, for example, if 30% have a disease and then an extra 20% have a disease, that means 50% when we add them have the disease. Then that means 50% again does not have. And it's for the same reason, if 50% have a particular disease and 30% have that disease, that means 80%, like let's say this is disease A and this is B, 80% are infected. 80% are infected. That means 20% is clean. 20% is clean. So, but if you try to apply this logic here and say, aha, 27% have the disease, and 35% have this disease. So when we add them, 27 and 35, you now get 12 to carry 3, 62%. So yeah, so you say 62% are infected. Therefore 100 minus 62, which is 2 year. No, that's not. This is 8. This is 3. So that means 38% are not infected. If you get 38%, you may be wrong. You will be wrong even, because this case here, what you are counting here, what you are counting in this area, we have done so now. What you are counting in this place here now is that only 27% have one disease and 35% have another disease. But then some people are actually overlapping. Like some people that have this disease A also have the disease B. So you may have counted them 2 times. So when you consider 27% with disease A and you consider 35% with disease B, these people you have considered here must actually be considered here. So you have to make sure that you don't overcount. Yeah, it will work for us if we add these 2. It will work for us. Likewise, if we add these 2, it will work for us. Different pen is necessary here. So if these 2, it works for us here, and these 2 as well, it works for us, but not really for these guys here. Not really for these guys here. So what we'll do, I will erase everything and we'll solve the problem in a more logical way. That is just an attempt we made to tell you how things can go wrong if you're not careful with analyzing the condition of the problem. You have to make sure you don't overcount. If you overcount, you may actually be missing the details, or you may be overusing the details. So let's see. Let's pick a different color from the one we have not used so far to analyze this question here. Okay, so no, we have used this one, magenta pen. Now let's see. What we do now is to look for overcounting. So let's do a diagram here. So this is those with disease A. I'll not say chicken pox because not really, I'm not going to dwell on spelling here. And I'll say this is German measles B. So here 27% have 27% have A, and then you have that 35% have B. 35% have B. Now 10% have both A and B. So how many have had neither? Well, let's find the one that have both of them. So we want to find A and B. Those that have A or B, like those that have both of them completely. We will consider A, this is 27%, plus B, this is 35%. But from this A part, we have counted 10. We have counted 10 in this A part. So now when we come here to 35 now and write 35, we also have counted 10 because 10% overlap both A and B. So we have to subtract the 10 since we counted it 2 times. When we subtract them, this will be 27% plus 25%. So that is 52%, I believe, because 25, yeah, this is 52 percentage. So 52% have both diseases. Exactly. So what about those that have neither? That would be 100 minus 52%. This is 48%. So our answer is 48%. Before we got 38%. That when we did it wrong, we got 38%. This shows you that we were actually overcounted by 10%. Like our work was erroneous. So the correct answer is 48%. If you're not careful in problems like this, you can blunder easily, really. So let's go to another problem and see what it has to offer us. So here we are asked to find in kilometer per hour. Let me get my pen. We have to find in kilometer per hour the speed of a train which covers 48 kilometers in 40 minutes. Now, when you hear per hour, kilometer, this dot is actually per. When you hear kilometer per hour, you are talking about speed. And there's a little formula for speed that is very interesting. I'll show you. It says that speed is equals to the distance you have traveled. The distance you have traveled all over the time it took you to make the travel. So that is the formula for speed. This galaxy pen. So this is the neat formula for speed. That speed is distance all over the time taken to make the travel. So let's find speed. So speed is distance is 48 kilometer. So 48 kilometer. And what is the time? 40 minutes. 40 minutes. But then we now have minutes, and they ask us in kilometer per hour, not kilometer per minute. So now we find out that we don't have to put 40 minutes here directly. We first of all have to put an hour here. Only an hour is accepted. So what we'll do is to go back to the problem and see how we can convert these 40 minutes that they don't want. We convert these 40 minutes to something in hour, 40 minutes to hour. And the way to do this is to realize that 60 minutes will give us 1 hour. 60 minutes will give us 1 hour. So when you divide both sides by 60, divide both sides by 60, you find out that a minute is 1/60 of an hour. So, but we need 40. So we multiply both sides by 40. So therefore, this is equal to 40/60 of an hour. Of course, the zeros cancel out. 2 here is 2, and 2 here is 3. So this is 2/3 of an hour. So in that case, instead of putting 40 minutes here, we'll put 2/3. 2/3 of an hour here. And when we have to do this, the 2/3 they invert, and this is 48 divided by 2 times 3. Yeah, 3 goes up. So 48, this is 24. 24. Yeah. So that is 24. Because that is 48. So 24 times 3. We'll now do 24 times 3. So this is 12. 2 carry 1. They make it 7. So this is 72. But we'll now put kilometer per hour, which is what they ask us to find. Or we may put a splash here. Kilometer per hour. Which is that to solve the problem, we only needed to know that speed is equal to distance divided by time. But then we'll be careful because it asks us in terms of hours and not in terms of minutes. So we'll not blunder like that. If I use minutes, it will be a blunder. So like sacrificing your queen on move 2 in chess. So let's go to the next problem and see what it has to offer us. Okay, yeah. We are asked to calculate the area of the shaded portion in the figure below. So the unshaded portion represents a sector. And what do they mean by a sector? That's what we have to find out first. This problem may look intimidating, but it's actually easy. Don't feel intimidated if you don't see why it's easy. So when we have a circle here, mm, of course, this is not the greatest circle in the world, but at least let's call it a circle. And let's divide it into 4 equal parts. The parts may not be equal, but we know, well, we actually get what I mean by that. Now, let's shade one of the parts here. So this part I have shaded here is called a sector. At least a sector of a circle, a sector of the circle. So you can divide this into 4 sectors here, but it only represents a sector. Like only this part is just assume this part is part of a big circle. So just assume it's part of a big circle this way. Not the best circle in the world, I know, but this is just what we have for now. What we have, we'll do with it. So this is what it means, that this part represents a sector. So let's see how we can solve this problem with the knowledge of this sector. Now what we do is that we cannot get the area shaded here directly because this figure here is an irregular curve, but we can use a very useful trick. This is what we do. We find the area of this rectangle here, the whole rectangle, and then assume this is the figure here. Okay, now let's say you divide this figure like into this part, like this. Let's use a different color here. So we have something like this now. Now assume that we try to shade this part. Let's say shade it in this color. So assume we try to shade this direction here now. If we want to know the area of this part we shaded, I can get the area of the rectangle. I'll call it rectangle. And then I'll subtract this part here that is unshaded. If I subtract the unshaded part from the rectangle, I will get this shaded part. So this is equals to shaded part. So if I get the rectangle and subtract the unshaded part, I will get the shaded part. So it is this particular knowledge we are going to use. We are going to observe that in this figure here, we have up here. In this figure here, let's get a pen. If we subtract this rectangle, from this rectangle, if we take away this white part, it will remain this part. It will remain this part only. If we take away the white part, so if we have the rectangle, so if we need the area of the white part, if we need the area of this part that is curved, this curved here, we have to take away the area of the white part from the area of the rectangle. Okay, so let's see how we can achieve that. So what we'll do first of all is what is the area of the rectangle? Actually, this is a square. This is a square actually, because these sides are equal, but a square is a rectangle just when the sides are equal. So this is a square here. I've been calling it rectangle, but it's still a square. A square is a rectangle with parts equal. So area of a square, the area of the square is 7 times 7. That is length times the width, which is 49 centimeters squared. That's area of the square. Now I have to subtract the area of the sector. That one is very easy because we know that a sector is 1/4 of a circle. So a sector, this sector here, is equals to 1/4. It's like a quadrant, 1/4 of a circle here. So this is 1/4. Let me write it here this way now. So this is 1/4. Let's wipe out. I don't think we need this figure again. So let's concentrate on this part here. So this is 1/4. This is equals to 1/4 of pi r squared, because pi r squared is the area of a circle. So the quadrant, this sector here, is 1/4 of the area of the circle. So we can do this as 1/4. I'll put pi, I'll put times r squared. You know why in seconds. So this is 1/4 times, this is 22/7. They always give us as pi. r squared, the radius of the circle. So this is the radius. This is radius of the circle is equal to 7. So this is 7 squared. And what I usually do, instead of putting down the 40 now, I'll now write, instead of putting down 49, which is 7, I'll write 1 over 4 times 22 over 7, but this will be times 7 times 7. So that I'll be able to cancel out 1 7. And then 2 here is 2, and 2 here is 11. So you have 11 times 7 is 77, all divided by 2. So you have 77 all divided by 2. So from this rectangle here, we are going to subtract the area of the square. We are going to subtract, so from this area, the area of the shaded portion, area of shaded portion would be area of rectangle minus the sector. So this will be 49 minus 77 all over 2. We have to multiply 49 by 2, 18, 98, right? So yeah, so 98 minus 77 all divided by 2. So 98 minus 77, that is 1. This is 2. So this is 21 all divided by 2. I think that is it for us. Very interesting problem. If you are feeling uncomfortable with it, it will need some getting used to. The only magic we did was, how do we know that we are going to subtract the rectangle from the sector? And the solution to that magic is because if you have a figure here and it's divided into some two parts here, if you want to find the area of the part, you can find the area of the whole and subtract one of the parts. Now we know this sector and we know the rectangle, so the problem is solved for us in this case. Let's see what the next problem has to offer us. Okay, here we are told that the sum of two numbers is 28 and that their difference is 10. Okay, so that is the key word there, the sum of the two numbers and their difference here. So first of all, here let the number be x and y. Let the numbers be x and y. So what do we know about x and y? We know that if we add x and y, that is some of the two numbers, we will get 28. So when we add x and y, we will get 28. And what do we know again about x and y? They are different. So if we subtract x from y or y from x, we must get 10. So there, x minus y is equals to 10. So usually we call this one equation 1 and we call this one equation 2. The way to do this is to add the two equations. It usually works because notice that here y is positive and here y is negative. So when you add both of them, they will be cancelled out. The reason is because we want to eliminate one of the variables to get the other variable there. Or you may even subtract them if you are ambitious, but addition is sufficient for our sake. So let's add the two numbers and see. Let's add the two numbers. So we have x plus y. This is the first equation, plus we now have x minus y. Second equation. This is equals to this and this, 28 plus 10. So that is what we get when we add the two equations. So what we'll do now is to observe that this is x plus y. You don't really have to put the bracket. I just put it to show you what we are doing. Plus x minus y equals to 28 plus 10. Now, x and x come together to give us 2x. Why they destroy each other? Because one is going this way and the other one is going this way. So we cannot really put them together. So in the nutshell, one is positive, one is negative. So they cancel and become 0. So this is equals to 38. Aha, so that is the last thing apart from dividing by 2. When you divide by 2, I think we'll get 17 here. No, let's 2. Let's see what 38. So this is 1, sorry. So this is 2. So this is 19. Okay, 19. So this is 19. Yeah. My division is not that good. So 19 is what we get. as our answer for one of the numbers only. Oh. Let's see how we can find that number. Let's see how we can find that number. Yeah. So having known one of the number is 19, we can simply come here and say, okay, uh, one of the number is 19. So x plus, okay, x was given as 19. So we know x is equals to 19, and then we know that x plus y, that x plus y is 28. So what that should give us here now is that from x plus y equals to 28, x plus, sorry, not really x this time around, but we remove the x and put 19, since we are already told that x equals to 19 equals to 28. So 19 plus y equals to 28. This will give us a 9. Y is 28 minus 19. This is that is 19, right? Nope, that is 9, because they say 28. Why do I not get this in right? So this 18, that is 9. So that is 9. That is 9. Okay, there. Because if we add 9 to 19, we get 28. So one of them, so this number, you have 19 and we have 9. So the sum them, you get 28. If you take the difference, you get 10. That will be all for the problem set. So this will be the last problem we'll solve in this video before we'll go to the next one. This is problem 6 so far. We're about to solve the 6th problem. So we are told that the area of the shaded region in the annulus of the ring, we have to find the area of this part shaded. Annulus, annulus is when you have a circle and you have another circle. This part between them is called the annulus of the circles, and you should find we should find the area of this annulus here. This tire, more like a tire. This the side of the tire. We should find the area correct to 1 decimal place. So the radius of the big circle is 40 and the radius of the small circle is 7. So you have a circle here and the radius is 14. Is the radius is 14. And you have another small circle here. And the radius is our radius is 7. I have to find the area of these two sides. Well, the way to go is to notice that if you have this big circle now, if you find the area and then we get this small circle now and get the area, if we take the big circle, let the area be A. If we remove the area of the small circle, what we call B, we have removed this part, and this part here. So the remaining part is the white part. This unshaded part is the one remaining that will be left if you take the difference in the area. Let me show you what I mean again. So you have a circle here. So let's say this is the area now. If you have another circle here, now if you take away the area of the big circle and take away the area of the small circle, what you'll be left with, let's see. So let's shade the small circle here. So what this is what you'll be left with. You'll be left with this small, let me put it in dark color. So you'll be left here. You'll be left with this. No, that's not dark. Hold on a minute. So you'll be left with this part here. So this is the annulus here. So what I have to do is that to find the area of the big circle and subtract it from the area of the small circle. So that is the winning idea to solve the problem. We get the area of the big circle and then we'll subtract it from the area of the small circle. Now what is the area of the big circle? So I've cleaned out the board now and we'll continue from where we stopped. So here now, what we have here is that The area of the big circle, area of the big circle, let's call it pi r squared. The big R, pi big R squared. And the area of the small circle, let's call it pi small r squared. Now the area of this annulus will be pi r squared minus pi small r squared there. So what we have, we can bring out the pi and we'll now get r squared minus small r squared. So this will be pi times the big R minus small r times the big R plus small r, because here we're making this difference of squares method here. So how do we now go? What is pi? Pi is 22 over 7 times, what's the big R? That is, big R is 14 minus the small r, which is 7, and then the 14 plus the 7. So what this will give us is 22 over 7 times 28. And of course, we are in log today. The 7 cancel out. We only have to find 22 multiplying by 28. Though it's not that easy to work out, but it's still something. It's not too hard. So let's see here. We'll get 16 and 4 plus 1, 5. So this is 16 as well. 5. So this is 6, 1 and 6. So this is 616 centimeters squared. So that is the area of the annulus of a, that is the area of the annulus or side of a ring. So thank you for watching the channel or watching the video, and please subscribe and hit a like. In the next video I'll solve 6 more problems. So have a nice day. Thank you.